Hi, okay, so let's launch into some applications of the exterior angle theorem. So what we should do, we want to arrange x, y and z here in question 3. Well, we can relate y and z through triangle ABE. So we see here that angle y here is the exterior angle. If we call this, let's say, alpha, then we can say that y as the exterior angle is equal to alpha plus z. All right, so what does that mean? It means that, well, which one's smaller out of y and z? Means that z must be smaller than y. Okay, so how can we then relate y and x? Well, let's look at this triangle here, DCE. And we see here that x is the exterior angle. Let's call this something like beta. Then we can say that x as the exterior angle is equal to the opposite two interior angles, y plus beta. So what does that mean? Well, it means that y is less than x. So let's put that all together. Which ones? Remember, it's ascending order. We should start with the smallest. So the smallest, I think we can see, is z. Actually, it's written just here, isn't it? Z, then y, then x. Okay, question 4. We've got an angle bisector. So that means that these two angles are equal. All right, so hence the same marking there in the angle. So what we should do is look at what this angle is. So use the triangle sum. So look at these two angles here, 56 and 48. They add together to give us 104. So that means that this entire angle here should be 180 minus that, so 76, which means that each one of these would be 38 degrees. Wonderful. All right, so then we're trying to find E and D, which are these ones here. So what we can do here is use the exterior angle theorem to make the calculations a little bit easier. Let's add these two opposite interior angles. We get 48 and 38. That gives us, what, 86? So that's going to be E is 86 degrees because of the external angle theorem. Let's use it again over here, add the opposite two interior angles, and we get, what's that, 80 plus 14, 94. And so 94 degrees is going to be the exterior angle of this triangle here. So we just used the external angle theorem rather than subtracting from 180. All right, so question 5. As a general rule, it's useful to look for things that we can see straight away. So if we try and use the exterior angle theorem, nothing sticks out straight away, but we can use this straight angle here. We see that there's 45 and B, so that adds to add up to 180 degrees. So we can see that B must be 135 degrees. All right, so now we can see a few things. We see that A plus C is 135. But what's going to be more useful to us is if we can use these x's. If we can find out what this value of x is, then we'd know those two angles there. And they're both exterior angles. Oh, and so is this one here. This is also an exterior angle. So why not use the exterior angle sum? So what do we have? We have 2x plus 20 plus 135 plus x minus 5. And that was all equal to 360. All right, so let's simplify this a little bit. We've got like terms, 2x and x. That's going to give us 3x. Adding up all this, well, that's 130 when we subtract 5. So 100 plus 150. Subtract that from both sides, and we get 210. Dividing by 3 gives us 70 degrees for x. So if x is 70 degrees, that means this is 65. If x is 70 here, that makes 140 plus 20 gives us 160 degrees when we substitute. All right, so then from here, I think we can see here, if that's 160, use the straight angle here for A to see that that's 20 degrees. The straight angle here for C, well, actually, no, rather than subtracting 180, let's use the exterior angle theorem. We've got, in this, what colour can I use? Red. In this triangle here, we see that let's just use the interior angle sum, 65, and subtract from 180, we get 115. Beautiful. All right, so in question 6, we've got the parallel lines here, shown with these arrows, and this is the notation for parallel, those double slash there. So when we have parallel lines, we can use the property of alternate angles. So these are interior alternate angles, so they'll be equal. So that's 50 degrees here. This angle over here is also equal. X will be this angle here. The name for that is interior alternate in English. Okay, so that doesn't seem too useful. Maybe what we can also look at is this straight angle here means that x plus y would be 130 to make up 180. So we can relate that now using the exterior angle theorem for this triangle here. Y plus 40 is the exterior angle, so we can say y plus 40 is equal to x plus y, the opposite to interior angles. But we know that that's 130, right? Because of what we saw there in the green. X plus y is 130 with a supplementary angle. So, sorry, that should be 40. So we subtract 40 from both sides and y would be 90 degrees. Using this, substituting back into here, if x plus y is 90, well, x has to be 40. So x is 40 and y is 90. Beautiful. So question number 7, this is a little bit of a trick question because some people are going to look at this and think that these lines are parallel so that these makes these angles equal. Well, that's a mistake because we're not told on the diagram or in the question that AB is parallel to ED. It's not written anywhere. So we can't use that information. Oops, we can't use that information. So what we can do is use the exterior angle theorem, of course, the theme of this video. So here it is. We see that 110 is equal to the opposite two interior angles. So to get y, we'll have to subtract 45, and that leaves us with a total of 65. And now 65 here for y. It's always useful to write in the numbers when you work them out, when you're problem solving. Now let's look at the bigger triangle. Maybe let's do it in red. ABC, we can consider 110 as the external angle for these two interior angles. So we can say 110 is equal to x plus 70. Now subtracting 70, we'd get x equal to 40. Okay, and we've found x and y. So hopefully this video you've learned a few different applications of where we can use the exterior angle theorem to assist in your problem solving. Best of luck, and I'll see you in another video.